Now we'll see a problem in quantum mechanics. I have taken this problem from Introduction to Quantum Mechanics by Griffiths and Sherother. It is regarding the harmonic oscillator and compute the expectation value of x position, momentum, x squared and p squared for the wave function psi naught and psi 1 by explicit integration. Here we have introduced a variable chi. Chi is equal to square root of m omega by h cross into x, and the constant alpha is equal to m omega by pi h cross whole power 1 by 4. And check the uncertainty principle for these states and compute uh, kinetic energy and potential energy for these states. Is there some what you would expect? So this is a harmonic oscillator problem. So for wave function, you have to take psi naught and psi 1. So psi naught is m omega by pi h cross whole power 1 by 4 e power minus m omega by 2 h cross into x squared. And if this a tagger acting on psi naught, you will get psi 1. A tagger is a ladder operator. So psi 1 is equal to 1 by 2 square root of 2 h cross m omega into m omega by pi h cross whole power 1 by 4 2 m omega x e power minus m omega by 2 h cross x squared. So psi naught is already have seen. If you put alpha is equal to m omega by pi h cross whole power 1 by 4 and chi is equal to m omega by h cross square root into x. And if you differentiate this one, we can get it is square root of m omega by h cross into dx is d psi. So psi naught, you can write this in terms of alpha and chi is psi naught is equal to alpha into e power minus chi squared by 2, and psi 1 is square root of 2 chi alpha e power minus chi squared by 2. So now you will find the expectation value of the position for the wave function psi naught and psi 1. For psi naught, it is integral psi naught star x psi naught dx, and if you substitute the value, then we will get the integral is in the function of it's an odd function. So the expectation value of x is 0. Similarly, if you do it for the wave function psi 1, here also the integral is odd function. So the integral is 0. So the expectation value of position for the wave function psi naught and psi 1 is 0. And now we have to find the expectation value of position momentum with the wave function psi naught and psi 1. And for this, it is integral psi naught star momentum psi naught dx. And this also you can write it as mass into dv by mass into velocity. So it is d by dx dt of expectation value of x. So if you do this, you can get it is equal to 0. So for both the wave function, the expectation value of momentum is 0. Now you have to find the expectation value of x squared for the wave function psi naught. And if you substitute this value, it is integral psi naught star x squared psi naught dx. And if you substitute everything in terms of psi, you can get it is equal to alpha squared h cross by m omega whole power 3 by 2 into 2 integral from 0 to infinity e power minus psi squared d psi. Here now you take t is equal to psi squared and dt is equal to do psi d psi. So if you substitute this, we can get it is equal to alpha squared h cross by m omega whole power 3 by 2 integral from 0 to infinity t power half e power minus t into dt. So this e power half you can write it as t power half we can write it as t power 3 by 2 minus 1 because we can write this as a gamma function, that is integral from 0 to infinity t power n minus 1 e power minus t dt is equal to gamma of n. So if you now here the integral is integral from 0 to infinity t power 3 by 2 minus 1 e power minus t dt. So this can be written as gamma of 3 by 2. So gamma of 3 by 2, gamma of n plus 1 is n gamma n. So gamma of 3 by 2 is half into gamma of 1 by 2. So gamma of 1 by 2 is square root of pi. So if you substitute this value, you can get it is expectation value of x squared is h cross divided by 2m omega. Similarly, you have to do it for psi 1, and you are representing first in terms of psi, and then you are taking t is equal to psi squared. And here in this case, you are getting it is 2 alpha squared h cross by m omega whole power 3 by 2 gamma of 5 by 2. So gamma of 5 by 2, we can write it as 3 by 2 into 5 by 2 into square root. So the expectation value of x squared is 3h cross by 2m omega. And now we have to find the expectation value of positive momentum with the wave function psi naught and psi 1. And for this, it is integral psi naught star momentum psi naught dx. And this also you can write it as mass into dv by mass into velocity. So it is d by dx dt of expectation value of x. So if you do this, you can get it is equal to 0. So for both the wave function, the expectation value of momentum is 0. And for the same thing for psi 1, we'll get the finally we'll get it is equal to minus 2 m omega h cross by square root of pi to integral from 0 to infinity psi power 4 minus 3 psi squared into e power minus psi squared d psi. So after the integration, we can get the expectation value of p squared is 3m omega h cross by 2. Now we have to find sigma x and sigma p. Is their product consistent with uncertainty principle? So sigma x squared is expectation value of x squared minus square of expectation value of x. If you substitute this, we can get h cross by 2m omega. For momentum, it is sigma p squared is expectation value of p squared minus expectation value square of expectation value of momentum, it is equal to m omega h cross by 2. So if you multiply these two sigma x and sigma y, you can get it is h cross by 2. So it is consistent with the uncertainty principle. Similarly, if you do it for psi 1, we can get sigma x squared is 3h cross by 2m omega, and sigma p squared is 3m omega h cross by 2. So we will get sigma x sigma p is h cross by 2. This is also consistent with the principle uncertainty principle. Now we have to find the expectation value of potential energy, kinetic energy, and total energy. For expectation value of potential energy, it is half m omega squared expectation value of x squared. So if you substitute, you can get it is h cross omega by 4. And for kinetic energy, it is half 1 by 2m expectation value of p squared, it is equal to h cross omega by 4. So the total energy is kinetic energy plus potential energy, we can get h cross omega by 2. So similarly, if you do it for wave function psi 1, it is equal to expectation value of potential energy is 3h cross omega by 5, and the kinetic energy is 3h cross omega by 4, and the total energy is 3h cross omega by 2.